Hey guys, welcome to Unit 10, Lesson 7. This is our last lesson for the unit. So get started with the warm-up. So it says match each of the following functions with the graph of the derivative. So on the left, you're given the original, and on the right, you're given the first derivative. So again, the synonymous for derivative is slope. So you're going to be basically looking out for the slope. So if I look at the first one, the slope is always positive. It is always positive, but I do have a horizontal line, horizontal tangent line at it looks like at x equals 3, right? So let's look at that. Where do I have? It is choice 3, right over here, and it's positive all along. It's above the x-axis, so that should be choice 3. This is 1 matches with 3, or C. I would say C. It says C here, right? Does that make sense? So next one, it is the slope is negative at x equals 1. That's where I have my horizontal tangent line. So it's negative before 1 and then positive after 1. Oops. And then it's positive after 1. So which one is that? So at 1 it is negative, so it's below the x-axis, and it's positive above the x-axis, so that kind of makes sense. So your second will be choice A, which kind of checks out. So let's see if number 3 is choice B. So if you look at your relative min and max are happening at 1 and 3, right? So oops, I don't know why it's changing so frequently. It's very touch sensitive today. So you do see that at 1 and 3 you are changing signs. Your first derivative is changing signs, right? And then it's a negative slope, then it's going at positive. At 1 it's changing signs at 1 and 3, so that kind of checks out with B. So choice 3 is B. So we're going to do more practice questions. Think very carefully about each question. So here for number 1, the graph of a twice differentiable function f is shown in the figure above. So it's telling us the twice differentiable part just means that the second derivative exists, and this is a graph of your f function. So it's very, very important that you know what the graph is given, okay? And it's asking us for which statement is true. And if you look at all your answer choices, it's talking about f of 1 and f prime of 1 and f double prime of 1. So it's talking about when x is 1. So since this is my original graph, f of 1 is what? 0. Now I'm going to use my knowledge of my first derivative and second derivative to determine what would it be at f prime of 1 and f double prime of 1. So f prime of 1, if you look at this, the slope is what? Positive, right? So means your f prime of 1 is going to be increasing, means it's going to be some positive number. Then your f double prime of 1 has to do with concavity, the shape of your graph. So if you look at your original graph, it is concave down. So it's concave down when your second derivative is what? Negative. So this is going to be negative because your graph is concave down, or a frowny face. So number 2, it says let f be a function that is continuous on the closed interval such negative 2, 3, such that f prime of 0 does not exist and f prime of 2 equals 0, and the second derivative is less than 0, meaning it is concave down for all x except x equals 0. Which of the following could be the graph of f? So we need the original graph. So it's saying it's continuous. So right off the back, it couldn't be choice D because choice D is a not continuous function. And it also says that the first derivative does not exist at 0. So if I look at 0 for C, my first derivative does exist. But for choices A, we have a corner, B, we have a corner right here at 0, and at E also we have a 0. So automatically we are out of choices C and D. Now, f prime of 2 is 0, meaning that you have a horizontal tangent line at 2, which checks out for A. You have a horizontal tangent line at 2 here, and we do have a horizontal tangent line, so that kind of really didn't help. And it says my second derivative is negative, meaning concave down. So if you look at each picture, that would be like actually the most important piece. If you look at this picture, I do have a smiley face here. So A is not the S choice. At B also, I do have a smiley face because it's saying it's concave down throughout over that interval, so it's not B, and it is choice E. So if you look at choice E carefully, it is concave down throughout, and it does not exist at, or your first derivative does not exist at. Number 3. So it's giving us a second derivative table, and it's asking us to tell which of the following statements must be true. First of all, your knowledge of second derivative. What does the second derivative give us? A second derivative tells us about our concavity and our points of inflection. So here, if you look at choices A, it's telling f is increasing. That is not told. We can't find that from a second derivative. Actually, a first derivative tells us that. Similarly, decreasing is also determined by the first derivative, and so is your local maximum or minimum. Your extreme values are determined by your first derivative. So automatically your choices A, B, C are out. Now you're looking at choices D and E. We are left with 2. So it's saying the graph of f has a point of inflection at x equals 1. So when do you have a point of inflection is when your second derivative is equal to 0 and the second derivative changes signs around 1. That's what it means, right? So if you look at 1, it is equal to 0, and it is going from a positive to a negative. However, this can't be the choice because we do not know all the points around 1, like what's happening at 0.9 or 1.1. Maybe at 0.9 it's going from a negative to a positive or something like that. So we really can't say it is true because we want to find it should be true all the time. So you're looking for the less specific choice. So look at choice E. It's saying the graph of f changes concavity on the interval from 0 to 2. So if you look at from 0 to 2, it is going from positive to negative. It's hitting 0. The sign change is happening. So somewhere around that, we don't know when, but somewhere around that, it is changing concavity. So number 4 is asking us to find the graph of the original function, and it's giving us that the first derivative is greater than 0, means it's increasing, and your second derivative is less than 0, means it is concave down. It has a sad face. So it's increasing, so automatically my choices C and D are out, right? It's not increasing, so choices D and E are C and D are out. And which one is concave down? If you look at this, A is concave, looks more like concave up. E also does not satisfy that. It looks like concave up, so we just left with choice B. Number 5. It says a polynomial p of x has a relative maximum at -2, 4 and a relative min at 1, 1. And a relative max at 5, 7. And no other critical points. How many zeros does p of x have? So let's sketch it. So it has a -2, a relative maximum at -2, 1, 2, 4, 1, 2, 3, 4. So it has a max here, and then a minimum at 1, 1. 1, 1 is that, and then another maximum at 5, 7, 2, 3, 4, 5, 6, 4, 5, 6, 7. So that is a maximum and no other critical points. So if I was to sketch it, right, I'm going to go like this. It has since it's a maximum, it's going to go from positive to negative, minimum, negative to positive, maximum. So since it has no critical values, my graph's going to go down. And how many zeros do we have here? Number 6. So here it's giving us a F table, and it's saying it's both continuous and differentiable over this interval, and it's asking us which of these statements must be true. So if you look at the choice A, it says the minimum value of F on 0 to 4 is 2. If you look at your interval from 0 to 4, it does look like, for the face value, it does look like it's 2 and it's true. But what is happening at 0.5 or 1.2 or any of those numbers? We don't know that. So it cannot be A. Similarly, at B, it's saying its maximum is 4, which it does look true, but again, we don't know what's happening between those numbers, right? There could be at 2.1, we could have 4.3 or something like that, so it couldn't be choice B. Choice C is saying f of x is greater than 0 between 0 and 4. So it's saying it's positive. It looks like it's positive all along, but we don't know exactly what's happening in between those numbers. So choice C is also not the right choice. So choice D is saying that the first derivative is less than 0 between 2 and 4. Less than 0 means my first derivative is what? Decreasing. So if you look at between 2 and 4, my y values are going down. They are decreasing, right? Is less than 0. They are decreasing, but we don't know for sure. Maybe they're decreasing and then they're increasing, right? So it can't be choice D. So that leaves us with just one choice. And let's see why it is true. So it says there exists a C between 0 and 4 such that the first derivative is equal to 0. First derivative equal to 0 means that you have a horizontal tangent line, meaning you have a critical value, meaning that you have those extreme relative minimums or maximums, right? So maybe so it is something like this. So you can argue that, wait a minute, we just said from 2 to 4 it is not decreasing. We do have one critical value. So that could be the case. So maybe it's decreasing and then it's increasing. So then we end up having even more than one critical value or more than one place where my first derivative is going to be 0. So it is choice E. Also, you could argue that what if there was a corner or at in between there? But here, if you look at the question, if you read the question, it said f is continuous and differentiable. So that cannot be even the scenario. So I want you to finish the remaining questions, and if you have tried those questions,